Okay, Assalamualaikum and very good morning. This video is for just some additional video to guide you how to obtain the result from the experiment one, because I believe that most of you might confuse a little bit how actually uh, according to the procedure in the lab sheet that you need to use a cursor feature to obtain your voltage, your result according to the tau given. Okay, as you can see from the experiments there, just don't confuse. Actually, the objective of this experiment, we want to obtain the voltage, okay, the voltage of each and every tau. Okay, for example, let's say during your pre-lab you already measure the tau. Okay, this one is you need to, that's why you need to do the pre-lab, otherwise you don't know what is your tau. Okay, because I also don't know your tau. It's according to your pre-lab. Once you calculate your tau, you need to know what is your tau. Is it how many I think millisecond or microsecond. So once you know your tau, okay, once you know your tau, okay, let's say you know your tau, your 2 tau and your 3 tau. Okay, so this one you need to measure, or you need to know, you need to obtain during pre-lab. Okay, there is a hand calculation that you need to done, then you know what is your tau. Then when you know once you know your tau, then you might know your 2 tau and 3 tau. Okay, once you identify your tau, then this experiment, what you need to do is, from the tau that you obtain, you need to observe what is the voltage, okay, from the uh, oscilloscope, from the oscilloscope screen, or in this online experiment, you need to see uh, in this grapher. Okay, so of course, in theory, okay, in theory, uh, the distance between this one, from this one should be, the origin should be 0 0. Okay, so at means that at t equal to 0 is here, and the voltage equal to 0 here. So from here to here is your tau. Okay, from that is your tau. So um, but this is in theory class. Okay, in theory, that is this is you at time t, this is your horizontal axis. The t is start here, which is the t equal to 0, this part. Okay, this point, the origin point. But in experiment, okay, doesn't matter is it a physical experiment or online experiment, if you are using oscilloscope as well, you also face the same problem. Once you generate the graph, you don't know actually what is, where actually the time where the t equal to 0, which is why we are using this cursor to find our tau. Okay, so that's why we need to, you use two cursor there. Okay, the first cursor is just as a reference, because as you can see, okay, that's okay. First, I want to clarify on the lab sheet first. Okay, the lab sheet here, that delta t is actually represent the value of, or the difference between one cursor to another. In other words, okay, because in physical experiments, when you are using the oscilloscope, um, when are you using the oscilloscope, then this actually represent the delta t in multi-sims is represented by delta x. Okay, but because in the physical experiment, that delta x is represented by delta t in your oscilloscope screen, so that is make you a little bit confused. But let's go back to this graph here. So in other words, if in the experiment you want to find your voltage here, what you can do is that, okay, you must put your first cursor here at this point. Okay, that is your cursor 1. And then later you need to vary your cursor. Let's say this is your cursor, and then I vary my cursor up until I find out that, okay, let's say this is my second cursor, and I need to make sure that my cursor different here, the horizontal different here, which is in multisim delta x, equal to my tau. Okay, so you vary your second cursor here up until you find out that your delta x equal to your tau, which is this one. This value you need to find during the free lap. Once you find that, then you take that voltage, because that is the voltage of your the voltage that you need to find when the t equal to your tau. Okay, so okay, I just show you one example. Okay, let's say like I said before, the first cursor you must put here. This one is for charging. It's just for charging. You put here, okay, and then you see this one, delta x. Once you see delta x, then you need to slide your cursor to up until the value equal to your tau. I don't know what is your tau. Once you find your tau, okay, then you just, okay, let's say my tau is, let's say that is my tau. Okay, let's say my tau is 30 microseconds, something like that. So then okay, because the it keep moving there, you can pause. Okay, you can just pause the result. Then you can just take the value of this point. Okay, this point is present by this one. So the point is 3.3. Okay, let's say I go back to, okay, assume that my tau is 22 microsecond. So now this represent the distance between this point and this point in horizontal axis. So it's a 22.879 microsecond, which is, I assume that is my tau. Once I find my tau, actually this V here is displayed by this second cursor, which is 2.94. So this is the value that you need to take and write it here. Okay, so in other words, this tau, actually this delta t is actually your tau. Means that once you doing a pre-lap, you know your tau, you must put here. So the times or the delta t of this one, and this one, up until all the experiment here, doesn't matter is it a theory or experiment, the t is obtained by your hand calculation. Okay, the difference is that only the delta v or the v itself, the v, this one is fill in based on your pre-lap, while this one is the value that you obtain from the multisim, okay, in the experiment one. But the t there, doesn't matter is it a theory or experiment, you need to use the result from the pre-lab. Okay, and what else? Yeah, that, just don't confuse. Actually, this one, delta v, actually is a v. V when, what is the value of v when the t equal to tau? So what is the, okay, don't confuse, because this notation have been put it here because we want because in oscilloscope normally we use the delta t, and while in multisim we are using the delta x, but the delta v actually is a v itself. V when your t equal to tau, and v when equal your t equal to 2 tau, and the v when the t equal to 3 tau. I hope that should be clear. Of course, later when you want to find the 2 tau, then you need to again vary your cursor up until your t equal to 2 tau, or your delta x equal to tau. So same goes to the discharging part. You must put the first cursor at this point, okay, and then you must vary your cursor here to find out up until to find out your, make sure that you must set your delta x equal to your tau, then you can take this value. Okay, I hope that thing is clear.